So we'll start now. Password was not working properly. Already we are late. I think we should start. The last time we were discussing the topic. Yes. Now next topic is multinomial coefficients. Multinomial coefficients. As you know, everyone, it's about the binomial theorem. Binomial theorem contains two terms, x plus y raised to the power n. Most of the students would have learned it in school level, I think 11th or 12th. It's nc0, x0, y raised to the power 1 like this. There are only two terms, x plus y, it is binomial. If there are three terms, x plus y plus z raised to the power n, it is trinomial. And if these are five terms, x plus y plus z plus t, then it is pentanomial. So, if we increase the elements in this way, x plus y plus z and so on up to n, so on up to n, it is not a binomial. All the coefficients, they are called the multinomial coefficients like NC0, NC1, NC2, NC3, NCn. Then what will be the coefficient of rth term in this expansion? That will be n factorial upon r1 factorial, r2 factorial and r3 factorial. We are concerned with only this bracket. Okay. No, its formula is not new for us. This formula we also used in the permutations. You remember in the words problem like distinct, we use it, total n objects and R1, R2, R3 are the different among the n objects. It is also called the multinomial coefficient in the expansion of this binomial is a1 plus a2 plus 1 up to a raised to the power n. So it is helpful us in solving the binomial theorems like this. Find the coefficient of x square y4 in the expansion of this. Simple. It is a binomial theorem. Everyone can solve it. That is equal to nc0, x raised to the power 0, y raised to the power 1, nc1, x raised to the power 1, y raised to the power 2, nc2, x raised to the power 2, y raised to the power 3. So, increase the powers of x and decrease the power of y. Somewhere in between you will get the term x square y4. And its coefficient will be the answer. That is the one method. But by using this formula, we can find the coefficient very easily like this. Here, n is equal to 6, r1 is equal to 2, this power, and r2 is equal to 4, this power. then the coefficient of this x plus y raised to the power 6 is equal to, use this formula, n factorial divided by r1 factorial into r2 factorial. 6 factorial divided by 2 factorial into 4 factorial. That is equal to, solve it, that is equal to 15. If we can solve the problem with the help of the binomial, then what is the use of this formula? Yes. Consider if these terms are 3, 4, 5, then it is very difficult to apply the binomial on this expansion. Like this. Find the coefficient of x square, y square, z square, t raised square, u square in the expansion of x plus y plus z plus t plus u raised to the power 10. It is pentanomial. It is pentanomial. If you try to expand it like the binomial theorem, it will take hours and many pages. And even we are not definite the answer will be correct or not. So this formula is helpful in such a situation, and the number of the terms are more than 2. Like this. Here, n is equal to 10, r1, r2, r3, r4, r5, 2. By chance, all the powers are same. All the powers are same. The formula is coefficient of this x square, y square, z square, t square, u square is n factorial upon r1 factorial, r2 factorial, r3 factorial, r4 factorial, r5 factorial. Put the values here and calculate it. So we can easily find the coefficient of multinomials expansions with the help of the formula. That formula was also used by permutation. That is the final answer. It's from your booklet, and its previous question was from your previous exams. Concepts are neither so typical, not so difficult, but only problem is that we, from the booklets, we don't know how to interpret or explain these topics, how these topics will convert into the marks in the exam. So, in other way, if there is a question in the exam from the topic, how we will identify it? If we will identify, then we will apply the formula. Next. Next is the pigeonhole principle. These are the radical concepts in the theorem. This statement is also important, pigeonhole principle. What it says, let there be n boxes and n plus 1 objects. Then under any assignment of the objects to the boxes, there will be always a box with more than one object in it. Simple. Simple example. We consider everyone, most of us, we go to temples in the religious places. What is the practice there? We keep the shoes outside the temple. And what is the procedure there? Is man sitting somewhere outside the temple. We give our shoes to him. He has a box. He keeps our shoes into the box and gives us a token. Okay? And in return, we give the token and take our shoes. It is a simple process, and we always let us consider an example. There is an arrangement of 4 100 shoes only in a temple. Your past practice, the management knows not more than 100 people are coming to the temples. So there is an arrangement of only 100 boxes to keep the 100 shoes there. And the practice is continued. A person comes, he keeps the shoes in a box and takes the token. No. And total boxes are 100. Now what will happen if someday there are 101 persons? See, it is a pigeonhole principle. In place of pigeon, we are considering the shoes. Then what will be done? A box, the man will keep the two shoes in the same box. If there are 102 persons, the man will keep the two boxes with the two shoes, and so on and so on. It is the pigeonhole principle. If he says there are the 100 holes and 100 pigeons, simple. Then can apply any method or any logics of the arithmetic and mathematics, there will be a box which will contain the two pigeons. There will be the two pigeons in 101. This is the pigeonhole principle. If there are n boxes and n plus 1 objects may be pigeons, or we have taken the example of shoes, then under any assignment of the objects to the boxes, apply any method, there will be always a box with more than one object in it. That is the pigeonhole principle. Now, what is the use of this principle in the mathematics? Let us see. It is a theoretical concept. It is not mathematical, not algebraical. It is a theoretical, logical concept. Let us see an example for this. If any set of the 11 integers is to be chosen from 1 to 20, show that we can find among them two numbers such that one divides the other. Answer is also given. It is a statement. We have to check this statement. But it says you have 20 numbers from 1 to 20, 1, 2, 3, 4, 5, so on, up to 20. And you have to select the 11 numbers from the 20. Remember, 11 numbers from the 20. Any 11s. Then he says, in the 11 numbers, there will be the two number. In 11, there will be the two number which will divide each other. We shall check the statement. Is it true or not? With the help of the pigeonhole principle. But let us start with grouping the integers from 1 to 20. Make the groups systematically, not randoms. Our purpose is to find the number which one divides the other. We keep in this way. 1 divides 2, like this. 2 divides 4. 4 divides 8. 8 divides 16. Okay. That is the first group. Then 3. Why? 1 or 2 is present here. 3. 3 divides 9. 9 divides 18. You will ask why we have not taken the 6. We are making the group systematically. 1, 2, 3. 3, after 3, there will be 4. But 4 is already selected. After 4, it is 5. So 5 divides 10, 15. Again, you will think 10 is left. No. Still we are on 5. After 5, it is 6. 6 divides 12. After 6, it is 7. 7 divides 14. After that, 8. 8 is already present. After it is 9. 9 is already present. No, it is the term of 10. 10 divides 20. Yeah. These are the groups in which a number divides the other. 11, 13, 12 is present here. 13, 14 is present here. 15 is present here. 16 is present here. 17, 19. These are the prime numbers. These are the 10 groups. These are the 10 groups. Simply, the situation is like this. You have the 10 holes. You have 10 holes and you have to fix the 11 numbers in these holes. Okay? These are the 10 holes, 10 groups. These are the 10 holes and you have fixed the 11 integers. Naturally, according to the principle, there will be a hole in which there will be the two integers. There will be the two integers. Two integers cannot be here. Two integers can only be here. This. And in all these groups, you see one number divides the other. One number divides the other. If we say you have to select 11 integers, select one integer from every group. One integer from every group. But no, to select the 11th integers, we cannot consider these groups. Why? There is only one integer. There is one integer. So these groups are out of the game. No. Left are the 1, 2, 3, 4, 5, 6 groups. If we select the second integer from any one of these, you have already one integer selected from this. No, you select any other number. You see, for example, rather you have selected the 3. No, you select the 9. 9 is divided by 3. In all the 6 groups, one number divides the other. From these groups, you cannot select the two integers. So we have left them. 11, 13, 17, 19. Two numbers cannot be selected. So if one number is selected from each of the 10 groups, only 10 numbers can be selected. You will select one integer from every group, only 10 numbers are selected. Then 11th number. To select the 11th number, we will have to go to these 6 groups. If we select the one second number from any one of these, then among the 11 integers, there will be the two integers which will divide, which one divides the other. To select the second number, only first 6 groups are possible. Therefore, two numbers have to be selected from the same group, in which one of them divides the other. It is the application of the Reynolds principle, or you can simply write it. There are the 10 holes for the 10 groups, and we have to adjust the 11 integers. So one hole for the one group will contain two integers. Will contain the two integers. And from here we see 1, 2, 3, 4, 5, 6. Any two integers, we select any two integers, one divides the other. It is a theoretical formation of pigeonhole principle. Now we convert this into the generalized form so that we can solve the numericals. That is the general form of the pigeonhole principle. It is a statement. Let capital K and N are the positive numbers. Let they are the positive numbers. If K balls, no, in place of pigeons, no, we have taken the K balls. K balls are put into the N boxes. let capital K and N are the positive numbers if K balls are put into the N boxes. The statement is, or you can say, if K pigeons are put into the N holes, then some box contain at least, remember this word, at least K by N. It is not bracket, it is greatest integer function. Remember, it is greatest integer function. Plus 1, it is a formula. So what is the greatest integer function? See, if by division the answer is 4.6, the largest integer is 4. So we select 4, D.6. It is not approximation, remember. 4.3 is also 4. 4.9 is also 9. 4.1, 4. 4.2, 4. Okay. Because here 4 is the greatest integer. Let's apply it on the bullets. In a group of the 40 students, at least, remember this word, at least, it leads to the generalized form of the pigeonhole principle. How many were born on the same day of the week? This is simple. Among the 40 students, how many have the same birthday? Remember, birthday. Total number of students is 40. It is K. And number of days in a week are 7. Understand the situation. It means you have the 40 pigeons or the 40 balls, and you have to adjust these 40 balls into the 7 boxes or the 7 holes. Then what the formula says? In every box there will be students how many? K by N plus 1. K is equal to 40, N is equal to 7 plus 1. 5.7 plus 1, 5.7, greatest integer 5. 5 plus 1 is equal to 6. Similarly, you can ask, in a group of the 40 students, at least how many were born in the same month? In the same month. But month are the 12. At that stage, you will take N is equal to 12. Here may be the two options. It is a generalized form of the pigeonhole principle. They are very important in numericals. Let us see. A drawer contains 10 black and the 10 white socks. What is the least number of the socks one must pull out to be sure to get the matched pairs? Often it happens we keep the socks into any box, into the drawer or into our almirah. But when we are in hurry, we take out the two pieces of the socks. We see one is black, other is blue. Often it happens. There is a same situation here. There are the 10 black and the 10 white socks. What is the least number of the socks one must pull? How many socks he must take from the drawer so that he gets at least one pair. Either it is pair of the white socks or it is pair of the black socks. Simply, there are the 20 socks. 20 socks have to be assigned in 10 pairs. We have to find out the 10 pairs. The K is equal to 20. K is equal to 20. Total socks are 20. And number of pairs is equal to 10. Simple case, you have to adjust the 20 balls into the 10 box. So the least number of the socks one must pull out greatest integer function K by N plus 1, that is equal to completely divided. 2 plus 1 is equal to 3. A man must pull out the 3 socks at least, then he will get the one pair of the same color. Similarly, see this numerical. It's from your booklet. The first one is also in your booklet, and it's also from the exam. This is also from the exam. Suppose 479 students are enrolled in the formula consisting of these 6 units. Simply, as we are studying, let us consider 479 students are enrolled in the mathematics, discrete mathematics. And there are the 6 units. That's it. At this time, in every study center all over the India, students are studying this topic, discrete mathematics. At least how many are studying the same units? So we want to see at least how many are studying the same units. Again, k is equal to 479 and number of units is equal to 6. It means you have to adjust 479 boxes in balls into the 6 box, or you can say 479 pigeons into the 6 holes. Then each hole will contain at least k by n plus 1. K 479 by 6 plus 1, 79.8, greatest integer 79 plus 1, that is equal to 80. It means at least 80 students are studying the same unit. So it is a application of the pigeonhole principle. Sorry. Example of the node application is example of the pigeonhole principles. They are very important numericals. These are see next. Principle of inclusion and exclusion. This time there was a 5 marks numerical. Did everyone receive got a PDF I sent last week? Yes? Hello?
No, sir.
Hello, sir.
No, sir.
No, sir.
No.
It was in the
No.
group. It was in the main group.
In the first group they received it. You did not save. Let me ask you. सर ये जो ग्रुप चल रहा है इसको मैंने पीडीएफ दी थी लास्ट टाइम, तो इस ग्रुप को नहीं मिली अभी। हाँ जी है क्या, तो दोबारा से निकल कल वालों को तो मिल गई थी, इन्हें नहीं मिली अभी है। अभी कर देना सर। No, you will get it. I think they forgot to send it to you. The group 1, all of them, they have received it. It's a question paper and many questions are solved in it.
Thank you, sir.
Principle of inclusion and exclusion. We want to go into the main theory. Simply in the logics you will read about the signs. It is sign of the conjunction. Conjunction means and. You remember this. It is sign of the and. Conjunction, and it is disjunction. Okay? Or we call it or. A or B, and we read it A or A1 or A2. A1 and A2. It is and it is or. In logics you will call it conjunction and disjunctions. TTT, true, and here FF, true. That's in the logics we will discuss about this truth tables. How many numbers between 0 to 999 are not divisible by either 5 or 7? There are the two types of the numerical here. The one was in exam from 1 to 1000. It is Mukesh. These are there are the two sets, not two integers, two sets. First set we say those numbers which are divisible by 5. Second set, those numbers which are divisible by 7. The formula is A1 or A2. These lines shows the numbers in A1 or A2. Numbers in A1, this shows number in A1 plus A2 minus A1 and A2. It is a simple formula. Then how to calculate the number in A1? Numbers in A1 is equal to, it is the greatest integer function. Who is A1? Which are number which are divided by 5. Total number are 999 divided by 5, that is equal to 199. It is the greatest integer function. Similarly, how many numbers are in A2? A2, who is A2? The numbers which are divided by 7. 999 divided by 7, that is equal to 142. And number in A1 and A2, that is equal to 999 divided by both A1 and A2. 5 into 7, that is equal to 78. Place all the values in the formula here. The numbers in A1, this numbers in A2, numbers in A1 and A2, total 330. It means from 0 to 99, there are 330 numbers which are divided by 5 or 7. But his requirement is which are not divided. So what we do? The numbers between 0 to 99 not divisible by 5 or 7 is equal to 999 minus 330 is equal to 686. That is the answer. This time the numerical was of 3 sets in your exam and the worth was 5 marks. Let us see. 3 number problem. Among the integers 1 to 200, find the number of the integers that are divisible by 2 or 5 or 9. Simple. This time these are the 3. A1 is equal to set of integers between 1 to 200. These are 200 integers total. Divisible by 2. A2 is equal to set of integers divisible by 5. And A3 is equal to set of integers divided by 9. For 3 set, the formula is this. No, remember this formula? A1 or A2 or A3. The number of elements in A1 or A2 or A3. These lines we read in this way. Is equal to A1 plus A2 plus A3 minus 3 A1 A2 A1 and A2 minus A1 and A3 minus A2 and A3. Simply A1 A2 A2 A3 and A1 A3 plus A1 and A2 and A3. We have to find all these one. What is A1? See, A1 is 200 divided by 2. 200 divided by 2. A2, 200 divided by 5. A3, 200 divided by 9. Again, remember, keep in mind, it is the greatest integer function. Okay, if you divide the 200 by 9, it will become 22.22. 22.22. So greatest integer is 22. In the same manner, A1 and A2, 200 divided by whose A1? A1 2, A2 5. That is equal to 20. A1 A3, 200 divided by 2 and 9. 11. A1 and A3, 200 divided by 9 into 5. A2 and A3, 4. Then A1, A2 and A3 is equal to 200 divided by 2 into 5 into 9, that is equal to 2. Place all these results here, you get that is equal to 129. So between 1 and 200, there are 129 numbers which are divisible by 2 or 5 or 9. If he asks note, then subtract 129 from 200. You will get the numbers which are not divisible by 2 or 5 or 9. So this time the numerical exam was numbers from 1 to 1000. 1 to 1000. I have sent you the solution also. You can see from there. So these are the 2 options of the principle of inclusion and exclusion. Then again, it's an important topic. Well, statements are very large, but the answer is very small, only 2 lines. It is a de-arrangement, application of the inclusion and exclusion to the de-arrangement. De-arrangement means when we break up the selections or the arrangements, then we break up the arrangements. For example, let's say we have 5 books and the 5 children. We give 5 books to the 5 children. All the books are different. One is math, physics, chemistry and so on. Then we take the books back from the students. It is a degeneration. And when in the evening they are going home, again we return them books. We return them books. So, keeping in mind, no one student get the same book which he received in the morning, which he received in the morning. Okay. In this way, we can find the number of ways of dearrangements, as we found the arrangements in the permutation simply, or we can find the probability of the such number of the ways of the dearrangements. Simple probability we know that there is a total number of the outcomes in favor of the event divided by the total number of the outcomes in the favor of the experiment. Event divided by experiment. No. First of all, concentrate on the formula. It is a basic formula, no need to struggle with it. If we simplify it, we will get this. You have to remember only these two. N factorial into e raised to the power minus 1, total number of the dearrangements of the n objects. Just we have taken the example of the 5 children. So here we can write the 5 factorial in the 5 factorials into e raised to the power minus 1. Okay. So you can find the value of the e raised to the power minus 1 from your calculator. Since calculator I think is not allowed in your class, you can also find it from your mobile. If the mobile is also not allowed, then remember the value of e raised to the power minus 1. In mobiles, simply you can find the value of this, plus e, then cap, then minus 1, you will get this 0.367. Then remember this value. Okay, the formula is this. If you can find the value, then learn it. If you have the calculator, you can see the value from this calculator, or directly you can remember this formula. It's a simple one. As I give you the example of the 5 children, for n is equal to 5, that is the answer. 5 factorial into this, into 5 factorial. Let us see this example. Let n books to be distributed to the n children. N books and the n children. So he can convert n into the 10, 5, 7, 8. Only it's just like a theorem. Then books are returned and distributed to the children again later on. As we discussed earlier, books are distributed to the n children. Then we take the books back from the children, and later on in the evening again we give the books to the children. In how many ways can the books be distributed? No, this distribution is, first of all, we have break up the chain. First we gave the books, then we have taken back the book, so that no child will get the same book. In how many ways can distribute the books in the evening so that no child gets the same book which he received in the morning? Corresponding to the each first distribution, there are n factorial into e raised to the power minus 1 ways of distributing the books. It is a dearrangement formula. For what? When we gave the books and take back the books from the students. It is n factorial into e raised to the power minus 1. This is the formula. Simple. Again, in the evening, we distribute the books to the students. In how many ways we can distribute to the n students? That is equal to n factorial ways. N factorial ways. So the total number of ways are n factorial into e raised to the power minus 1. And that is equal to n factorial whole square into e raised to the power minus 1. So you will ask, where n factorial comes. N factorial, it is a arrangement when in the evening we return the books to the students. It is the final answer. Just like theorem. No, in question sometime he asked there are the 10 students, there are the 8 students, then here put the value of n and then put the value of e raised to the power minus 1. This 2-line answer is very important. It's also from your exam, a booklet and exam both. In the same manner, we can find the probability in this way. Here statements are very long, but answer is only 2 or 3 lines answers. Again, it's from your question paper. It is based on the probability. Suppose 10 people have exactly the same briefcase which they leave at a counter. The briefcases are handed back to the pupil randomly. What is the probability that no one gets the right briefcase? Simply like the books, that 10 persons say they go for a meeting. Everyone has a briefcase. Everyone has a briefcase. We take the briefcase from all the persons and keep it in the counter. Then after the meeting, when they are going back, again we want to return the briefcase to the executives or the persons. Now here he wants the probability, but in first American his requirement in how many ways. But here his requirement is what is the probability? No one will get the same briefcase. No one will get the same briefcase. Here, number of the persons 10. Total number of the possibilities of distributing the briefcase is equal to 10 factorial. 10 factorial. Then the number of possibility in favor of event. Then degeneration n factorial into e raised to the power minus 1, 10 factorial into e raised to the power minus 1. If the requirement was in how many ways, then we multiply the both. The answer will be 10 factorial square into e raised to the power minus 1. But here he wants the probability. Probability means event divided by experiment. The probability no one will get the right briefcase is equal to 10 factorial e raised to the power minus 1 divided by 10 factorial. It cancels. Answer e raised to the power minus 1. That is equal to, put the value here, 0.36788. If he wants the percentage, what is the percentage of chances? Then multiply it by 100, around about 36.7%. Chances no one will get the same briefcase. So these are the two different options. If we multiply both, when the requirement like this. How many ways? In how many ways can the books be distributed? Then we multiply. But this time, what is the probability? This section is common to the both. This section is common to the both. You can say it's a very small topic, probability. The probability is a simple probability we have in the syllabus. Guessing is probability just like guessing about an situation. In the simple probabilities, we discuss about the two main things: experiment and the event. So what is an experiment? So you have a coin. Throwing a coin, it is an experiment. And coming of a head or a tail, it is an event. It is an event. If we throw a coin, the total number of the outcomes in favor of event, in favor of experiment, 2 raised to the power 1. If we throw 2 coins, the outcomes of experiment 2 raised to the power 2. If we throw the 3 coins, 2 raised to the power 3, and so on. If we throw the 10 coins, then outcomes in favor of experiment are 2 raised to the power n. Similarly, for a dice, throwing a dice or ludo dice, it is an experiment. It is an experiment. Coming of a number, any number, coming of number 1, 2, 3, 4, 5, 6, it is event. Coming of odd number, coming of even number, coming of a prime number, all these are the different events associated with an experiment. So we are concerned with the outcomes. Outcomes means in how many ways an experiment can happen. So if we throw a dice, then total number of the outcomes are 6 raised to the power 1. If we throw the 2 dice, total number of the outcomes are 6 raised to the power 2. If we throw the 3 dice, total number of the outcomes are 6 raised to the power 3, and so on, and so on. Similarly, in the case of cards, we have deck of the 52 cards. If we draw a card from the deck of 52 cards, it is an experiment. It is an experiment. So total outcomes of the experiment are 52. So what are the different events? The card drawn, it is a black, it is a red, it is a queen, jack, it is 3, 4, and so many events associated with this experiment. So these are the two terms which will again and again use experiment and the events. Simply how to find the probability: outcomes in favor of event divided by total number of the outcomes. Outcomes means in how many ways experiment or a event can happen. The probability of any event always lies between 0 and 1. It is never greater than 1 and not less than 0, or it means it is never negative. Probability is never negative and never it is greater than 1. If the probability of an event is 1, it is a sure event. How? Let us consider we have a coin, both sides having head, then we will throw the coin, head will come. It is a sure event. Probability of A is equal to 0. If it is 0, we say it is an impossible event. How? I say throw a dice, what is the probability of coming number 7? It is impossible because 7 number does not exist on the dice. Next one, in probability not happening of any event. How we calculate it? Not is equal to 1 minus yes. First of all, calculate the event in yes and subtract it from 1. By 1, total probability is always 1. Let's see an example. A dice is rolled once. What are the probabilities of the events? They are different. Getting an even number, getting at least 2, getting at most 2, getting number 10. There are different events. It's only for practice. When we roll a dice, we throw a dice, then here it is part of the sample space. 1, 2, 3, 4, 5, 6. The total number of the outcomes 6. Any number can come. It is the total number of the outcomes of the experiment. The first event is getting an even number. We write in this way: A is equal to event of getting an even number. What are the even numbers? 2, 4 and 6. These are 3. These are 3. Then probability of over event is equal to NA upon NS. What is NA? N is outcome of the A event, or NS means outcomes of the experiment. 3 by 6 is equal to 1 by 6. This is the basic probability. See, next event is getting at least 2. Where the word is at least 2. How to solve it? First of all, we write the event. A is equal to event of getting at least 2. Then write its outcomes. At least 2 means 2, 3, 4, 5, 6, and their number is 5. Their number is 5. So the probability is NA divided by NS. It means outcome of event divided by the outcome of the experiment. 5 by 6. Similarly, getting at most 2. At most 2 means 1 and 2. 1, comma 2. Here NA is equal to 2. Probability of NA by NS 2 by 6 is equal to 1 by 3. Then getting 10. It is impossible event. Why? 10 does not exist on a dice. 10 does not exist on a dice. So these are the few basic examples of probability. So see this example. 1 minute please. Give me 1 minute. Yes. Now ABC are the 4 candidates. Then A, B, C, D are the 4 candidates for the post of the chairperson. Suppose A is twice as likely to be selected as B. Simply, the probability of A in selection is twice that of B, and B is twice as likely as C. and C and D are equally likely to be selected. What are the probabilities of their selection? Simply, are they related to each other? So we start with the minimum. Let us chances of selection of C is equal to X. Therefore, chances of selection of D is also equal to X because C and D are equally likely. No. What is the chances of selection of B? So B is thrice as C. It means 3x. And A is twice as B. And selection of the BA is equal to 6x. So add them. Total outcomes are 11x. It is our sample space. Total experiment 11x. Then probability of selection of A simple 6x by 11x, 6 by 11. Probability of B 3x by 11x, x cancels with x. Probability of C and D x by 11x is equal to 1 by 11. It is simple basic numerical. Let's see a concept. In a binomial theorem, the number of the given binomial coefficients, given means NC0, NC2, NC4, NC6 is equal to number of the odd binomial coefficients, and both are equal to 2 raised to the power n minus 1. Okay, because the total number of the binomial coefficients are 2 raised to the power n. Remember it. In a binomial coefficients, the total number of the binomial coefficients are 2 raised to the power n, in which even binomial coefficients are equal to the odd binomial coefficients. Even means NC0, NC2, NC4, NC6, and odd means NC1, NC3, NC5. Both are equal. Both are equal. Next important numerical is very important. Based upon this binomial concept, a coin is tossed n times. What are the possible ways that the head will occur an odd number of the times? If we will throw a coin n times, what he wants, what is the probability head comes on every odd number? Every odd number means 1, 3, 5, 7, 9. But the total number of the attempts are n. So, if the head comes in the first throw from the n, then it is NC1, then it is NC1. If the head comes in the third throw from the total, there are n throws, it is NC3. First we write the outcomes of the experiment. Coming of head in n throw is equal to 2 raised to the power n. As I told you, if we throw a coin n times, the total number of the outcomes are 2 raised to the power n. It is the ns, which means the outcomes of the sample space. No. A is equal to event of coming head in the odd term. If the head comes in the odd terms, it means in NC1 or NC3 or NC5 or so on. Here NC or means, I told you plus, or means plus. It is the addition theorem. Later on we will discuss it, the addition theorem. It means NC1 plus NC3 plus NC5 plus so on. All these are the binomial coefficients. These are the even odd binomial coefficients. Odd binomial coefficients are 2 raised to the power n minus 1. So probability of A is equal to Na by Ns 2 raised to the power n minus 1 divided by 2 raised to the power n is equal to 1 by 2. That's the answer. Similarly, he can ask the answer for the tail, or here from odd he can write even also. See more. A coin is tossed n times. What is the probability of getting the R heads? What is the probability of coming R heads? These are the general numericals. The number of ways coming head in the nth row, as we discussed earlier, 2 raised to the power n. It is a total sample space. A is equal to, let me say, event of getting R heads. Then NA, number of outcomes of the event are NCR, CNR. It means R out of N. Then probability of A, NA by NS, NCR divided by 2 raised to the power N. No need to calculate it, leave it here. Leave it here. It's also from your exam. No doubt. The next see, all these numericals, they are from your previous exams. 2 dice, 1 red and the 1 white are rolled. What is the probability that the white dice turns up a smaller number than the red dice? Simple. We have the 2 dice, 1 red and the 1 white. We throw the both dice simultaneously. So what is the probability that on the white dice there is always a lesser number than the number on the red dice? For example, if it is 2 on the red dice, then it is 1 on the white dice. If it is 4 on the red dice, then it is 3 or 2 or 1 on the white dice. Total sample space, we throw the dice twice, 6 is equal to 36. No the need to write the sample space. A is equal to event, number on the white dice is smaller than the red dice. Such things we can write the sample space in this case. Start from the requirement is number on the white dice is less than the red dice. See, if there is 1 on the white dice, 1 on the white dice, on red dice, it may be 2, it may be 3, maybe 4, maybe 5, maybe 6. Okay. No, change the number on the white dice 1. If it's 2 on white, then on that it will be 3, 4, 5 and 6. Again the chain is finished. No. If the number is 3 on the white, then on that 4, 5 and 6. Because on the red, number is always greater than the white. If it is 4 on the white, then on red it is 5 and 6. If it is 5 on the white, then it is 6 on the red. It's all over. Because 6 cannot come on white. Because There is row number 7 only. Let how many outcomes are there? They are 15. Count them, they are 15. Simply, the probability is NA by NS. 15 divided by 36, that is equal to 5 by 12. So there are very small topics are left, but the marking scheme is good one from this one. That's the probability. Then we shall discuss the method of proof. Then principle of mathematical induction. All these topics are they are very small topics, but the marking scheme is very large. Then is the addition theorem. Addition theorem, as we discussed in case of the coin, when there is more than the two events in an experiment. Here we shall discuss only the two events, A or B, or C, or D, or E. Or means plus, A or means plus. If in an experiment there are the two events A or B, then happening of A or B, we write A or B like this: P A union B, it means or, is equal to PA plus PB minus P A intersection B. Intersection means both, and or means union means it is union means or. Here A and B are not mutually exclusive events. Mutually exclusive means when we write the outcomes of A and B, if there are some common outcomes in A and B, then we say they are not mutually exclusive. But in the case, if the outcomes of A are totally different from the outcomes of B, then we say A and B are mutually exclusive. If they are mutually exclusive, then their intersection is zero. Zero means a null set. Zero means a null set. It means their intersection is zero. If A and B are mutually exclusive, then A intersection is equal to 5. Then this result converts into PA union B is equal to PA plus P. When it is used when the A and B are mutually exclusive. Mutually exclusive means both A and B do not have any outcome common in them. We shall discuss the examples. How can we interpret the outcomes are common and the outcomes are not common? It is two cases of an addition theorem. Let us understand this concept. Everyone know about the cards. We take an example of card. A card is drawn from a deck of the cards. What is the probability? Number one, it is a king or a queen. Addition or theorem. It is a card of spades or a king. There are the two numericals. We shall discuss it one by one. Wait for 1 minute, please. See, NS is equal to 52. NS means outcomes of the experiment. Total sample space 52 because there are 52 parts. No. There are the two events. A is equal to event the card is king. B event the card is queen. A or B. No. You know how many kings are there? There are 4 kings. There are 4 kings. And how many queens are there? 4 queens. Do you find any card which have both king and a queen? No, there is no such a card in the deck of the cards. It means A and B are mutually exclusive. Mutually exclusive. They have nothing in common. They have nothing outcome in common. Because a king is a king and a queen is queen. It means A and B are the mutually exclusive events. So the formula is PA union B is equal to this one. PA plus PB. PA means NA by NS, formula put equal to, plus PNB by NS, NA means 4 by 52, plus NB, it is NB, again 4 by 52. Total 8 by 52, that is equal to 2 by 13. It is the case when the A and B are not mutually exclusive. Now we will see if they are mutually exclusive. It means there is something common between them. Note down it. The second part is, it is a card of spades or a king. Again, or it means addition theorem. Let us say A is equal to event the card of spades and B is equal to event card is a king. You know how many card of spades are there? 30. And how many kings are there? 4. We write it. NA is equal to 13, number of spades 13, NB is equal to 4, kings are 4. But no, A and B are mutually exclusive? No, they are not mutually exclusive. See, you find a king of spades. Is there not? There is a king of spades. It means they have common property. They have common properties. It is intersection. It means one card is king of spades. A intersection B is equal to event king of spades. And that is equal to 1. That is equal to 1. No. A and B are not mutually exclusive. So formula is PA union B is equal to PA plus PB minus PA intersection B. Change into the formula NA by NS, NB by NS minus NA intersection B by NS. Put all the values, you get the answer 4 by 13. So do it. Let us see one more example. Find the probability of getting the sum 9 or 11 in a single throw of 2 dice, or means again the addition theorem. The question is, if you throw a dice, what is the probability of coming sum on the dice? If you 9 or the 11 in a single throw of the 2 dice, sorry. You throw the 2 dice, There are the different number on the two dice. What he wants, find the probability. The sum of the number on the both dice is either 9 or the 11. Either 9 or the 11. Still we don't know either it is a mutually exclusive or not. That will be clear only when we write the sample space for the events. First of all, the sample space of the experiment ns is equal to 6k, that is equal to 36. Okay. No, first event of getting 9 as the sum on the both dice. How to find the outcomes? See, sum is 9. We throw the two dice. If 3 is on the first dice, on the first dice, 1 cannot come because if there is 1 on the first dice, 8 should be on the second, but not possible. If it is 2 on the first, then 7 must be on the second, not possible because 7 and 8 are not print on the dice. If it's 3 on the first dice, then 6 on the second. 4 on the first, 5 on the second. 5 on the first, 4 on the second. 6 on the first, 3 on the second. Here the sum is 9. Here the sum is 9. Here are the total outcomes 4. Total outcome 4. No. B is equal to the event of getting 11 as a sum. How the 11 will come? 5 on the first dice and 6 on the second, or 6 on the first and 5 on the second. That is 2. Now check, is there any outcome common between A and B? No. No. It means A and B are mutually exclusive. A and B are mutually exclusive. Apply the formula and this is the answer. Complete it. It is 1 by 6. Complete the numerical. Let's this. In a 10 questions, true and false exam. There is exams, there are the 10 questions. You have to write only true and false, just like it's a coin, head or tail. A student must get 6 or more correct answers. If she selects her answer by guessing, what is the probability she passes the exam? A student attends an exam which is a true and false examination, and it contains the 10 questions. Condition is that a student will pass the exam if he attempts the 6 or more. Getting 6 or means 6, 7, 8, 9 or 10 correct answers. There is a student who guesses the answers. He does not know the answer, only guesses the answer. What is the probability she will pass the exam? Or means, it is a addition theorem. You see, total sample space 2 raised to the power 1. How? We will say true or false. There are the two options. This is just like a coin, head and tail. 2 raised to the power 10. There are the 10 questions. So A is equal to the event of getting 6 or 7 or 8 or 9 or 10 correct answers. Then she will pass the exam. It means 6, if she attempts a 6 right answer from the 10, it is 10C6 selection plus 10C7 plus 10C8 or 10C9 plus 10C10. Now she has to select from the 10. Then probability of A is equal to NA by NS. NA is equal to this and NS is 1 by 2 raised to the power 10. Keep the answer in this way, or if you have time, you at home you can solve it. This I have solved it. She passes the exam. That is the final answer. Note down it. Is there any problem? All these are theoretical topics. Let us see. Again, it's from your booklet. Suppose A and B are mutually exclusive events. It's given already. Such that PA is equal to 0.3, PB is equal to 0.4. What is the probability A does not occur, A or B occur, either A or B does not occur? These are the 3 parts. All the values are given. No. First of all, first part, A does not occur, means P A bar. Not means P 1 minus P. No is equal to 1 minus S. 1 minus 0.37, it is given 0.7. A or B occurs. A or B का मतलब A union B is equal to PA plus PB. Why this formula? Because they are mutually exclusive. Again, answer is 0.7. Either A or B does not occur. P A complement union B complement. Bar means say complement. It is equal to P A intersection B complement. It is a De Morgan law. It is a De Morgan law. Reverse we have used it. That is equal to A intersection B is 5. Why it is 5? Because A and B are mutually exclusive. If A and B are mutually exclusive, then their intersection is 5. And the complement of 5 is always 1. And the complement of 1 will be the 5. That is the answer. These are the 3 portions. It's about the basic probabilities. Now there is a small topic from your first booklet. It is the method of the proof. In the methods of proof, the most important numerical, only we will discuss about that. But that is the method of contradiction. This numerical was also in exam this time, and this work was 5 marks. It was same numerical here which we are discussing now.
Sir,
it's totally basic. Yes?
You may explain this last one, third part of previous question?
Yes. This one.
Yes, sir.
This one. It is the third part.
Yes, sir.
Here we have used the De Morgan law from the set theory. Okay. I have discussed the maximum from your previous exams. And this time, I don't know which was. That you received a PDF or not still? Hello? You got the PDF?
Yes, sir.
Yes, sir. We got it.
I received.
So today you go through the question paper and the answers. Next time you tell me what is the problem. Okay? So, the method of proof is a very. There are many theorems in this unit, but we shall discuss only one. It is the most important one. Method of contradiction. Nothing is new. All we have done it in the school up to the 8th level. But the procedure was different there. Now we shall discuss it in the fresh mind and with the fresh theorems. It is a method of contradiction. See the statement, show that root 5 is irrational. Similarly, the numerical can be root 3, root 7, root 11, root 2. You have to change only the figure. If it is root 3, then in place of 5 write 3. If it is root 2, in place of 5 write 2 and make the small changes. Before understanding the solution, now, statement is we have to show that it is an irrational number. We shall prove this theorem by the contradiction. Contradiction means, if possible, let root 5 is rational. No. What is a rational number? Rational number is like this. Everyone know P upon Q. Is it a pure rational number? See, 4 by 6. 4 by 6, it seems to be a rational number. But 4 by 6, you can divide it by 2. 2 to the 4 or 2 3 the 6. Or you can say 2 is common in numerator and the denominator. In the denominator. Rather, it is a rational number. But numerator and denominator, they are not co-prime. They are not co-prime. What is the meaning of co-prime? No, A and B are co-prime if they do not have any common factor except 1. Like this, 3 by 7. It is also a rational number. We cannot divide them. We can number. 4 by 10, rational number, but 4 2 as a common factor. 2 as a common factor. It is the backbone of our theorem. It means we consider here the rational number which are only co-prime. Which are only co-prime. It means they do not have any common factor. Any common factor. Now again we started. Show that root 5 is irrational. We will prove it by the method of contradiction. If possible, let root 5 is rational. If it is rational, let root 5 is equal to P upon Q. Take it number 1. Q is not equal to 0 and it is the main consideration. P and Q are co-prime. Now you should be aware of this result. Co-prime means like number are like this. They have no common factor in numerator and denominator except 1. See the procedure? It is fixed for all. It is fixed for all the numericals of this family. Squaring both sides. 5 is equal to P square upon Q square. Cross multiply P square is equal to 5 Q square. Now, think if we carry the 5 in the denominator of p square, we write it means 5 divides p square, is it or not? It means 5 divides p square. And according to the arithmetic, if a number divides an square of a number, then it's divide the number also. If 5 divides p square, then 5 also divides the p. No, a number will divide any number only if 4 is divided by 2. Why? Because 4 is in the table of 4. 4 has a common factor as the 2. It means 5 divided p, it means 5 is the factor of p. It means 5 is the factor of p. Second number. If 5 is a factor of p, then 5 will divide the p. Then 5 will divide the p. 5 is the, then if 5 divides the p, then 5 is the divisor, p is the dividend, and say r is the quotient. R is the quotient. Yes, written or not here? Let me see. The result was 5 is a factor of p. It means 5 divides p. If 5 divides p, then let p is equal to 5r. P is equal to 5r. So, put this value of p in number 2 here. It will become 25r square is equal to 5q square. It means 5r square is equal to q square. It means 5 divides q square. We carry the 5 in the denominator. This implies 5 divides the q square. If 5 divides the q square, it means 5 divides the q. It means 5 divides the q. Again, the theorem of arithmetic. If a number divides the square of a number, then the number also divides the square root of the number of the number. Similarly, if 5 divides 25, if 5 divides 25, then 5 will divide 5 also. Then the 5 will divide the q. It means 5 is the factor of q. It means 5 is the factor of q. Here the result number 3 says 5 is the factor of 3. It says the 5 is the factor of q. It means 5 is a common factor between p and q. It means 5 is a common factor between p and q. 5 is a factor of both p and q. If 5 is a factor of p and q, it means p and q are not co-prime. It means p and q are not co-prime. It will create problem. Why? In the beginning we have written p and q are the co-prime, but here the result is come. Result is p and q are not co-prime. Why there is so contradiction? Because our assumption was wrong. Our assumption was wrong, which contradicts the assumption. Therefore, root 5 is irrational. Therefore, root 5 is irrational. So, in this way, you can do any numerical of this family with root 2, root 3, root 7, root 11, anywhere. Is it clear? from very beginning. You can see it again. This is the first part. This is the backbone of the numerical. P and Q are the co-prime. Okay. First we prove 5 is a factor of P. Then we prove 5 is a factor of Q. It means 5 is a common factor of P and Q. It means P and Q are not co-prime. Okay. Which contradicts our assumption. That is the main idea for it. Next time we shall discuss the principle of mathematical induction. Again, it is important. This time the numerical from this topic was 8 marks. But maximum the worth is 5 marks from the principle of mathematical induction. Then comes the recurrence relations. First we shall discuss the principle of mathematical induction, then about the recurrence relations. Next time we do it, we'll start it EMI. Now let us see the previous question paper. This is a question paper. December 2021, marks 100. It's logics. You will get the extra class. See, it is, we discussed, show that root 5 is irrational using the proof by contradiction. In every session we always do it. The work was 5 marks. Now you remember this numerical? A is equal to B, this B is equal to this, find A cross B, A cross A, and A cross 5. I have solved it. Its work was 5 marks. It was 2, 2 and 1. A cross 5 is equal to again 5. This we shall discuss in the next class. See, this numerical. Determine the number of integer solutions of the equation, 4 marks. We discussed last time. How many 3-letter words we discussed in the combinatorics. I have solved it again. 4 marks, 3 marks. You can see the it's all from the graph theory. Now see, next time we shall do it. Explain the principle of the mathematical induction. Same numerical. 8 marks. It was 8 marks. Then it was find the power set of the set. Already we have done it. See, already we have done it. Rather, I have solved it again for you. This one we have already done it. 4 marks. 4 marks. You can see there are how many? 3 marks. Rather, I have left the many things. Even you see the marks in the exam. 7 men or 5 women. time we discussed the 5 men or 5 women sit in a circle. I have solved it and sent to you. This one also today we discussed. What is the probability that the number between 1 to 1000 is divided by 2, nor 3, nor 5? Inclusion and exclusion principle, 5 marks. So, there are many marks there. So these are the solutions. You can see most of the questions. All these ones, you can see I solved it. This is from the numerical equation from number 1 to 1000. Okay. Next time we shall discuss the principle of mathematical induction with a fresh mind. I am also tired.
Sir, I have a doubt. One question I have put in the chat box.
Yes.
One question I have, sir. I have put in the chat box. Sir.
This one. In how many ways 20 persons can be put in 5 groups? 20 P5. Yes? Are you listening me?
Yes, sir. Yes, sir. I am listening.
20 P5. Simple. It is arrangement. P5.
P5.
I have solved it. Okay? It is from the permutations, not this combination. Okay, students. It's enough for today. Next time with the fresh mind we shall discuss the topics. The problem is that time is limited and the syllabus is unlimited. And we have to manage between the both the barriers. Okay. The next time we shall discuss. Okay, have a good day, students.
Have a good day, sir. Thank you.